Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to add and subtract rational expressions with unlike denominators. So let's get right to it. In order to add or subtract rational expressions, you must have common denominators, okay? So how does that work? First things first, you want to rewrite each denominator in factored form. Number two, you want to find the least common denominator, or LCD. Step 3, you want to rewrite equivalent rational expressions using the LCD by multiplying the missing factors to both the numerator and denominator. Step 4, you want to then go ahead and add or subtract the numerators and keep the same denominator. And step 5, last but definitely not least, you want to go ahead and simplify the rational expression that you're left with. So let's get to some learning. Let's go ahead and find the sum or difference of the two rational expressions in simplest form. State any restrictions on the variable. Okay, so we have 3 over 4x squared plus 7 over 14x. They're already fully factored, so we just need the common denominator. And the common denominator between 4 and 14 is going to be 28, of course. So let's go ahead and label that. Our LCD here is 28. And the least common denominator between x squared and x. Please remember that for polynomials, it always belongs to the highest exponent. So you have an x squared here. You have an x to the first power. So it belongs to the highest exponent, which is 28x squared. So now, just like we learned prior lessons, what am I missing here from 4x squared? What do I got to multiply to 4x squared to make it look like 28x squared? And you got it. You just need to simply multiply a 7 to both numerator and denominator, giving me a 21 over 28x squared. Plus, what am I missing over here in this second rational expression? What do I got to multiply to 14x to make it look like 28x squared? You got it. You're going to multiply it by 2x to both numerator and denominator. That's now going to give me 14x over 28x squared. Now you're going to add or subtract the numerators. So this will be 14x plus 21 over 28x squared. And now I'm going to simplify. So I'm going to factor out a 7 from the numerator, leaving me with 2x plus 3 over 28x squared. And then last but not least, simplify. So I can take a 7 away from here, leaving me with 1, and a 7 from the 28, leaving me with 4. So my final answer will be 2x plus 3 over 4x squared. Let's go. And that's how you do it. Nice and easy. All right, let me go ahead and shrink this here for us. Give us some more space. Okay, number 2. First things first, what is the LCD, the least common denominator? Well, again, for polynomials, it always belongs to the highest exponent of that particular polynomial. So x plus 3 is raised to the first power, x plus 2 is raised to the first power. So that there is my LCD. X plus 3 times x plus 2. So what do I have to multiply to this x plus 3? Well, I'm going to have to multiply an x plus 2 to have the same common denominator. And what do I have to multiply to this 3 over x plus 2? The missing part of the LCD, which is x plus 3 to both numerator and denominator. Okay, so let's go ahead and convert the rational expressions now. So I've got a negative x minus 2 over x plus 2 times x plus 3. And then remember that this is a negative here. They're subtracting. So you're really going to have to distribute the negative 3 here to everything over here, the x plus 3. So this becomes, you can now go plus negative 3x minus 9 over x plus 2 times x plus 3. And now I have a common denominator. So I'm going to simply add or subtract the numerators and keep the same common denominator. So negative x minus 3x is negative 4x minus 11 over x plus 2 times x plus 3, which is the common denominator. And then I'm going to go ahead and simplify by factoring out a negative 1 from that negative 4x minus 11, creating 4x plus 11 over x plus 2 times x plus 3. And there you have it. Okay, let's continue. Get a little bit more complicated now. First things first, let's go ahead and rewrite the rational expressions in fully factored form. So I've got here, this is going to be x minus 2 times x minus 1. How did you get that? Remember, what times what is 2, but when added together is negative 3. Next thing we're going to check for is the LCD. And the LCD here in this case will be x minus 2 times x minus 1. Please note, it is not x minus 1 squared. The power of this x minus 1 is 1. The power of this x minus 1 is 1. So that is the highest exponent of that particular polynomial. Okay, so what am I missing over here in the first term? I'm missing an x minus 2, which I'm going to multiply to both numerator and denominator. I'm not missing anything in the second rational expression that I have. So now I'm going to go ahead and distribute my x. So that's going to render me with x squared minus 2x plus 2x minus 1 over x minus 2 times x minus 1. That will then, when we simplify, give me x squared minus 1 over x minus 2 times x minus 1. Then I factor to simplify. This is a difference of squares, so I have x plus 1 times x minus 1 over x minus 2 times x minus 1. The x minus 1's cancel, and I am left with x plus 1 over x minus 2, and we're done. It's not that bad at all. Okay, next, let's go over here to example 4. First things first, we're going to rewrite each of these rational expressions in fully factored form. First one is already factored. This negative can already be distributed here, so you could say plus a positive 2, because a negative times a negative is a positive. Then I'm going to factor out an x from the denominator. My LCD is x times x minus 1. What am I missing over here? An x. I'm not missing anything on this second polynomial, so I don't have to worry about that, or second rational expression. So now I'm going to go ahead and distribute. So I've got x squared plus x plus 2, and it's all over the denominator of x times x minus 1, because we already created a common denominator. And we cannot factor that any further. We cannot simplify that, and we're done. Now, some people may say, Mr. Morrow, can I get rid of the x's here? No, you cannot cancel out individual pieces of polynomials. Next, okay, number 5. Remember what we got here? When we fully factor, you always want to have the leading coefficient positive. So from here, I'm going to go ahead, I'm going to go ahead and factor out a negative 1. And I'm going to bring that negative 1 up to the numerator. As I said, it's going to avoid complications. So I've got a negative 1 over n minus 1 plus 2n over n plus 1 n minus 1. My LCD here is n plus 1 n minus 1. So I'm going to multiply my missing n plus 1 to the numerator and denominator of the first rational expression. The second rational expression is already set up with the LCD. This gives me negative n minus 1 plus 2n. I add all the numerators, and I keep it over the same denominator of n plus 1 times n minus 1. Simplify, go ahead and combine like terms in the numerator, which will give me n minus 1 over n plus 1 times n minus 1. The n minus 1's cancel, and I am left with 1 over n plus 1. Done. All right, let me go ahead and shrink this up to give us some space here. All right, number 6. First things first, factor each rational expression. So I got x plus 2 over an x times x minus 2. And then again, we can go ahead and distribute this negative now or later. I'm going to go ahead and do it now. So then I go plus a negative x minus 2 over 2 times x minus 2. What is the LCD here in this case? The LCD here is going to be 2x times x minus 2. What am I missing over here on the left rational expression? A 2. What am I missing over here on the right rational expression? An x. So let's go ahead and distribute. So I've got 2x plus 4 over, of course, my common denominator of 2x times x minus 2. And then I've got plus, distribute the x, I've got negative x squared minus 2x over the common denominator of 2x times x minus 2. Let's go ahead and combine the numerators. Let's add or subtract the numerator and keep the same denominator. So I've got a negative x squared. The 2x and negative 2x cancel, and that's plus 4 over 2x times x minus 2. I can go ahead and factor out a negative 1 here, giving me x squared minus 4 over 2x times x minus 2. And I'm going to have to shrink this up for our last step here, because if you notice, I can go ahead and factor the numerator here because it's a difference of squares. So I've got a negative 1 times x plus 2, x minus 2 over 2x times x minus 2. Cancel out the x minus 2's, and my final answer will be a negative x plus 2 over 2x. A little bit longer process there, but still nice and simple. Okay, number 7. Let's go ahead and, first of all, rewrite the rational expressions in fully factored form. I'm going to go ahead and distribute this negative right off the bat, making that a plus negative 6x plus 7 over x minus 2 times x minus 1. My LCD here in this case is x minus 2 times x minus 1. I'm going to multiply x minus 1 to this first rational expression. The second rational expression already has the least common denominator. Now I'm going to go ahead and multiply these. I'm going to FOIL. So I've got x squared plus 3x minus x is plus 2x minus 3 over x minus 1 times x minus 2 plus a negative 6x plus 7 over x minus 2 times x minus 1. Now I have common denominators. I'm going to add or subtract the numerators, which is going to give me x squared minus 4x plus 4 over x minus 1 times x minus 2. The numerator is factorable. It's a perfect square, actually, so it's going to be x minus 2 times x minus 2 over x minus 1 times x minus 2. The x minus 2 cancel with this x minus 2, and I am left with x minus 2 over x minus 1. Let's go. All right, last but not least, what if I have 3? Don't stress it. I've got 5 over n minus 2 plus 5 over n plus 2. Got this negative here. I'm going to distribute it to the 20, make this a positive. So I've got negative 20 over n plus 2, n minus 2. My LCD here in this case will be n plus 2, n minus 2. So I'm going to be multiplying n plus 2, which is the missing factor to this first rational expression. I'm going to be multiplying, let me move this plus here, give me some space, n minus 2 to both the numerator and the denominator of the second rational expression, and the third rational expression already has the LCD. So let's distribute here. So I've got 5n plus 2 over n plus 2, n minus 2, plus 5n minus 2 over n plus 2 times n minus 2, plus a negative 20 over n plus 2 times n minus 2. Now I can add the numerators or subtract them and keep the same denominator. So I've got 5n plus 5n is 10n. 2 minus 2 cancels out, so this is, I'm left with 10n minus 20 over n plus 2, n minus 2. I can factor out a 10 here, rendering me with 10 times n minus 2 over n plus 2, n minus 2. The n minus 2's cancel, and I am left with 10 over n plus 2. And there you have it. I hope you learned a lot. Thank you for watching, and come back anytime. Take care now. Bye-bye.